Hi, I'm Tom and I talk about code. Welcome to another Rust programming live stream. Today I'm doing more work on my compiler. Last time I started writing a tokenizer and a Lexer, and it came a little late in the project. I had a working programming language and I had this weird parser combinator system that never actually tokenized my input. And so last stream I changed that. Off camera I've done a bit of work on a Lexer, which is really cool. So now I don't just have a token, like for example, oh no, what's this dot doing here? Where did this come from? If you have the number 7, for example, right? As a token, this is the string 7. But once you lex it, you turn it into a number that is 7, right? You turn plus into, a symbol that is plus. You annotate these things with some type information, and in the case of numbers, convert them into actual numerical values from a string. So that is nice. That means that our parser has to do even less work. When we do something like look for an expression in our code, now instead of having to ask, is this thing a number, by analyzing the contents of a string, we just ask if the token that we have is of type number. This works a lot better. This means that we basically just do less work and it simplifies things. Let's have a look at that. Let's have a look at my new expression parsers, okay? Expression literal int. For one thing, this now no longer cares about base 16 versus base 10. They're the same thing now. That happens at an earlier stage of handling our input. If we look at the Lexer, when we lex a number, we try and either do a base 10 or a base 16 number. And this actually uses the parser structures that my whole parser used to be based on. So we use these parser structures to consume the string content within a token to then convert it into a lexed token that has a type associated with it as well. So when we look for a number, we say, hey, is there another thing in this input? If there is, and it's a number, then we give it back. Otherwise, we expected a number. Otherwise, if there's nothing left in our input state, we're at the end of the program. So the way we do errors looks a little different. And one of the cool things about now being able to generate an error from a token means that if we look at how our lex token is defined, for example, we're generating an error from a token that has a line number and a position in line. This means when something goes wrong, and let's try this, let's cargo bin test.code. I think this breaks. Bin lang. Cool. So this says that it failed at line 0, position 0, which is not very useful. So it says up here. That probably means that it's failing to parse this entire thing, or something in the entire file. So I've got some problems combining errors, right? Because sometimes you'll have multiple errors, you need to work out which one was correct. So this doesn't always work, but in theory, for more specific errors, we're going to get a good type. Now, one of the problems at the moment, probably the biggest problem, I think we build at the moment. We build. But if I run my unit tests, it's going to yell at me a bit. So there's quite a few unit tests that fail. And one of them that fails is testing for globals. Now, that would explain why we're getting an error at line 0, position 0, because if it doesn't know how to parse a global, then it's going to really struggle with that. So let's have a look at some of these things that fail. So test size of is actually a pretty simple one. If we look at our expression tests, test size of. So this test is extremely simple. We're looking for our size of built-in. Okay, so what could be going wrong here? Now let's run this. Let's just run tests in the language package that contain size of, or just size, I guess. And we can see I get a little bit of output here from my failing test, which is nice. I've told it to give me a bit of information back. We can see the entire token stream, which is cool. And what does it say? At line 0, position 0, we expected to see the token size of. What do we get here? The first thing we see, line 0, is a symbol size of. So this is interesting. This is interesting. If we have a look at our Lexer, because I haven't shown any of this on stream, I did all of this off stream. The way our Lexer works, it's very similar to how the Tokenizer worked before, actually. The way it works, it tries to handle this thing as a string, as a number, as an identifier, and then if it doesn't work as any of these things, it gives us back a symbol. So symbol is kind of like, this thing's not an identifier, but it's a bunch of characters try and do something with it. So things that would fall through to here would be, for example, you know, left bracket, curly brace, parentheses, plus, minus, equals, all this cool stuff. If we look at our tokenizer, we also have, I forgot, we tokenize our bigraphs as well. This is good. This is really, really valuable. So some of this work is maybe split between two places that shouldn't be. Anyway, that's a side quest. That's a side quest. The important thing is that size of is falling through to symbol here. For some reason, size of does not appear to be a valid identifier, which is kind of weird. So what we ask here, right? What we ask here is, does this thing satisfy a character predicate, or is it just the literal character underscore? So does it satisfy the predicate of being an alphabetic character, not alphanumeric? An identifier can't start with a number, and an identifier has to start with, you know, A, B, C, D, E, or an underscore. So this feels right. So why might this not be matching? And actually, before we get too far into this, right? So this is probably the place that this test is going wrong. But if we go back to running every test, let's try another one. Let's try test array index, and let's see if it's a similar test. Array index. Okay, so that's this one, yes. This appears to be different. This actually appears to be related to binary operators. Is there another test that does a similar thing? Expression deref? Let's look at test assignment. Let's look at test assignment. What happens here? Line number, expected identifier. So this looks very, very promising. This looks very promising. Oh gosh. Let me just remove a very interesting user from my chat. Beautiful. Okay. Statement. So it looks like if we're looking for an identifier, let's have a look at this test, this statement test, assignment, parser. So it's looking for an identifier at the first thing, and it's not finding it. And I suspect this is because we get we get a symbol instead. I suspect nothing is ever a valid identifier, and that's why so many of these tests are failing. So let's go in here. Let's go into my test harness, right? I do the lexing. This is a macro because reasons. Maybe doesn't need to be. It did because of lifetimes, but now maybe it doesn't. Let's just println the tokens that we lexed, okay? Now, this output will only be visible if the test fails. So this is kind of a nice way to just visualize only in failed tests exactly what we got. And indeed, we can see that what should be parsing as identifier is coming out as a symbol. So we need to look at our Lexer, and we probably need to write a test, because our Lexer is entirely untested. Also, here's a really important to do. We currently don't handle characters at all. Nothing is ever a character as far as our Lexer is concerned, so our program will never see a character, like a character constant, for example, something like this, wrapped in single quotes, C style. Oh, that's good tea. Okay, so let's write a test. Let's write a test for the Lexer, and let's see if we can work out what's going on here. Mod test. And this is a good example of when lack of tests can really cause subtle, quiet issues. So let's call it let's call it Lex identifier. So what do we need? We need a token stream. So let's say let input equal foo bar baz. We need to tokenize this, then we need to lex it. And okay, so we'll say let tokens is equals tokens input. Beautiful. And then we have this wonderful little thing, which I'm going to copy and paste. It probably should be a helper somewhere. It exists too many unique places now. Cool. Okay, so we have the Lexed tokens. The Lexed tokens. And you're going to notice a couple of janky things, right? Like this weird function signature, because we have two kinds of token. We have token that's been lexed and token that hasn't, and we need different things. It's a bit of a mess. It's a bit of a mess. There's a better structure here. There's a better way to pass this information around, but we're not there yet. We're not quite there yet. So what I really want to say is assert equal. I want the first thing that we've lexed to be lexed token let's just say, let's do it the manual way. Let's do it the extremely manual way. Lex token. Do we have a new from? Okay. We're going to do it the extremely manual way with curly braces. So we're going to say that this line number 0 position in line 0 and value is going to be lexed token kind identifier foo. And we're going to say that this is the same as lexed get 0, lexed first unwrap. We're going to run language tests, and we are going to run every test with lex in the name. And this needs to be toString. I'm also going to need to grab use crate language tokenize tokens. We're going to need to grab this function as well. It's going to be an important function. All right, so let's see what happens now. Parse error, unknown. Crate. Cool. That's actually pretty good. That's pretty good. It's a nice error. Parse error on. Oh yeah, I forgot to actually import the thing from it. Parse error. And also parse error kind, of course. Parse error kind. What's this? Lexed token. We don't have an equal for it. So I think we should be able to derive, right? We should be able to derive this, but we're gonna have to derive partial EQ on a few structures underneath. So this is partial EQ. This is going to have to be partial EQ. This will be fine because all of the things inside it, including this one I just added it to, right? You can derive partial EQ for a struct or an enum if all of the variants or fields are themselves partial EQ. So once we've added up here, we can add it here. And then here we should just be able to say partial EQ. And this now will work almost. We need to make it a T instead of a ref T. Cool, and now it fails. And it fails for the reason we think. Value identifier, value symbol, right? We want it to be an identifier, but for some reason, my Lexer never wants anything to be an identifier. It hates, it freaking hates identifiers. It's really, really upset about anything like this. So repeat 0 can never fail. So this is fine. Indeed, even map erroring this is a bit troublesome. We can probably just unwrap, right? Repeat 0 literally never fails, but that's okay. We'll keep the map error because it seems like good practice. So this feels good. This feels good. Incomplete. Huh. So it could be this, right? Indeed. Let's do some dumb debug printing. Because the exact details of this error are going to get lost. But let's see. Yeah. Okay, that would be it. So why do we have something left at the end of this string? Let's, even better, let's print out what is left in the tail of this string. And let's wrap it in double quotes so we can actually see if it's white space. We can do this without leaving them. Vec car can't be formatted. rest.toString. I hope vetcar has an override for toString, like a special, that's not what I want, a special case one. Vetcar can't be formatted, of course it can't. We have to do this one. We have to do this one instead. And that's okay. That's okay. Okay, that looks really promising. That looks extremely promising. So for some reason, repeat 0 is not taking anything. It's not taking anything else. Rest. Ah, and do you know why that is? Do you know why this this is never working? It's a mistake I've made many times, and it's one of these fun, hilarious things where it's like, oh, this is me not understanding my own library. So in my parser combinators, right, you run a parser combinator, you get back the remaining state and the thing you parsed. So what happens here? We get back, we ignore the remaining state, and we get the rest of the thing we've parsed. So instead of checking if the remaining state is empty, like have we consumed everything here, I'm checking if there's anything, the rest of the identifier after the first character. That's why it's oo, are, and as, the rest of the identifier as I would expect it. So what I actually want to say here is rest, or maybe even just call this like state tail, maybe. If our state tail is not empty, because we're doing it right here, we're building the string correctly. That should have been a real giveaway. So now that passes. That passes beautifully. Indeed, I suspect most of my tests will now pass. The binary operator ones are still probably going to be broken, but more things just passed. The size of now works fine. Array index, this has a test with binary operators in it. So it's actually, if we fix bin ops, it's probably going to fix everything else. Expression cool, I'm not sure about. Struct fields, I'm not sure about. If and while make me nervous as well. Let's see if and while have more interesting errors. Expected token if. Expected token if. Now. This is actually probably fine. This is probably very easy to fix. Symbol. Okay. So I said before that anything that we couldn't parse as an identifier, so let's give an example of this as well. Let's give a better example of this. Let's say foo, right? This is an identifier. Okay, so we have this problem. And it's not really a problem, but it's the thing causing this bug right now. It's the main issue right now. Sorry, just gonna get rid of another spammer, not you, Cricket. Someone else. So what if we have a keyword like if that is a valid identifier, but we want to kind of reason about it more like it was just a dumb symbol like plus or something. Previously, I only had one function for doing this, but now I have a new one. I have a new thing called name, and I think I defined it in language. Name. Yeah, this one. So this is for a thing that's like a symbol, but it's actually an identifier. This is for keywords. Name. So anywhere we have symbol, but it's actually valid, I'm on the wrong thing. That's okay. That's okay. So a function name, it's like a function symbol. Awesome. Let me just pop out my chat real quick. We have Cricket. What's the longest chain of unique compile errors I've had to fix in a row? I honestly don't even know, right? Probably 50 to 100 in Rust. A lot. It's a lot. It hits a point where you don't keep count anymore. You just keep hitting CN to get to the next error, and you power through. So anywhere that I'm using this symbol function to check for a symbol, but it's actually potentially a valid identifier, I have to use this name function instead. This is a little bit of a deviation from how this used to work, but it's a good one. It's a really, really good one. Name. We're gonna have to do this for while as well. Name. I'm surprised that I didn't do this, because I definitely put a lot of thought into this when I did it the first time, and I wrote this name function. I'm using it a couple of places, just apparently not in my statement parsers. So this still fails. It still fails. Expression. I mean, this is nice at least. So we can see the expressions as they come out. The actual error is expected a semicolon at line 0, position 17. So let's look at our statement test if. And it's for foo bar. Well, this is a pretty good indication of what's going on. And this is why all this debug printing has been kind of useful. Symbol bar, semicolon. So we're not stopping consuming characters on semicolon. So we can fix that in our parser, in our tokenizer, sorry. Okay, so where do we break? And this is the set of characters that we break on. And this probably should be defined somewhere else so that it's shared, right? Otherwise, we take one or more of not these characters. So semicolon needs to be in here as well. Semicolon needs to be in here. Okay, anything that's not any of these characters. Are there any other special characters that I've missed? I guess like at and the pipe and dot. Dot's important. That would be why struct fields are broken. Let's do comma as well, even though I'm not sure if comma is actually significant. Are there any other characters that are important to my syntax? Let's do these as well. Ampersand, derefs, and frickin' pointers. Okay, I see why this has gone wrong. Hat, ampersand, bar, dot, comma. Let's see if this goes a little better now. Any of these characters. Now we don't want to take a single quote because we only want to do that if it's a string. So we should never be in that situation. This is written in an extremely specific way that should never fail. Cool. Well, that removed a lot of my errors just by matching the correct things. That's a really good sign. That's a really, really good sign. So expression call. So comma is actually important for function calls, right? Very, very important. Let's do that one. Let's lang call. Let's do our test expression call. Okay, now position 6 expected a closing bracket. It looks like we have one here. So in our example, we have an identifier. We've got a function called push. We've got an open bracket. We've got an A, and then we have a close bracket at line 9. We're saying that at position 6, what's at position 6? The symbol A. So we're seeing the symbol A, and do you know why that this is going wrong? It's going wrong because we don't know how to handle characters, like car literals. We haven't coded them yet. So we need to do that too. We need to break on this character. We need to add an else if. We need to say else if let okay sn res equals literal car. And I need to rewrite this function to be less disgusting because it really is making me uncomfortable at this point. I don't like looking at this function. Okay, so oh yeah, the other thing I did, I guess I didn't show that right, but I wrote this state for handling our input stream. It's called, I think it's in character, stir state. And this is a wrapper around a string slice that as we advance through, it keeps track of line number and what position we're in. It actually doesn't advance line number ever yet. Like there's a line feed function, but we never call it yet. But we will at some point, and then we'll just get line numbers for free, which is cool. So do I have a token? Well, yes, I have a token type. There's no token type. I have a lex type for it, which is good. So let's say let. So we're looking for the specific sequence of single quote, any character, any alphabetic character, alphanumeric character, any character. Wildcard. Do I have wildcard? Do I have... Well, I guess no, not car. Let's say not car. It has to not be that. You can't just have two single quotes in a row, but any other character is going to be valid. And then is car, and we have to remember to close this, is car. Excellent. And we'll map the error like above. And we'll go from stir state. This isn't really an error. This is just a no match, but we'll treat it like an error anyway. This parse error, we don't need parse error here. Parse error is too powerful an error type for this situation, but that's okay. That is okay. And then we just say, okay, we give back the successor state and we give back a new token, and it's gonna be a ref to this. Res is just a car, so that's fine. And that's it. That's all we have to give back. Oh, and then the line number and position in line input dot line number input position in line. Beautiful. We don't close that out with a semicolon. Does that work? Of course, something has gone on here. That has to be a string, so we don't need to escape it. Cool, so that builds, which is nice. We now have a token that might contain a character literal, a single character literal. Our Lexer, I don't think handles this yet. It does not. But that's okay, we can just copy what we've done for other things. Result. So this had a funky return type, weirdly with lower cases, but that's okay. This had a funky return type because I stole it from existing code that did this. So it returns a lex, a lex error. And I don't think I need to, I guess map is okay, right? Map is okay, so forget lift to state. We're gonna say not car this. We don't need confidence, we don't need any of this stuff. So if it is a single character wrapped in these things, then we want to map this into lex token new from. We want to take a lex token kind, that is a car. I guess we're just gonna have a special token type for this literal car. And we're gonna grab input.clone. I guess we have to clone it. I guess, can we take a ref? I don't know. Maybe this is a bit inefficient. Anyway, I think that works. Let's find out what happens. Lex car. Let's put lex car into the mix. Okay, so what did we miss? What did we miss? Oh yeah, we have to maybe map the error. And if we don't find this, we just give back this no match error, which is basically like saying, we tried, but the details don't matter because we'll just try something else. Now this actually should be a token. That was my mistake. Arguments to this function are incorrect. Expected a string state, found a token. Oh yeah, Yeah. True. Too true. This expects a string thing, so we have to just turn our input into that. So what we're basically saying is this is a new thing that we use to track the state of input parsing throughout our whole program, but now we're just applying it to whatever's inside this token. We're kind of bastardizing the same machinery for a very different purpose, but that's okay. That's okay. Expected this, found a result, string state. Yeah, wait, hold on. What do I want to do here? And then I maybe just want to map the state and the t just into a t. Right? Because then we just ignore the state. Perfect. Okay, that's what we want to do. That's what we want to do. So this is here we have a result, once we run this function, we have a result stir state lex token. Like it gives back two things. It gives back a tuple here. We can just map out of the tuple. And there might be a function that we could use instead of writing our own closure, but that's okay. That's okay. We'll just do it this way. So what if I test now? Okay, we're down to just 2 failures. So that's been a huge improvement just from a few simple things. Test declare and test function. Let me take a stab in the dark and look at my function. Function body, function definition, input, identifier, symbol, allow empty, symbol, function body is a symbol. Okay, that does look fine. That does look fine. Oh, I got rid of inline assembly. Where's that? Yeah, I had to comment inline assembly out. Inline assembly is too special a case for this at the moment. Yeah, oops. I didn't consider this when I started this refactor. So let's start with the simpler one. Test declare is going to be much simpler. Let's do t lang declare. So what happens in this test? We have a let something equals something, blah, 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 blah. Test declare statement declare. And that's going to be this thing again, name. Right? We told it that we were looking for a symbol, but actually we want an identifier that is a keyword. So now we're down to, wow, that got both things, of course, because the function body had a let in it, so that failed by extension. So that was really good. It would have been much harder to work out that that's why the function was failing, as opposed to just fixing the simpler test. Now, inline ASM. Where is inline ASM? It must be in... Where's this test? Oh, this is an actual test. An actual test. So this whole test just needs to be commented out. Cool, now everything passes. So that's amazing. That's amazing. And I'm just going to do a really dumb commit here, and I'm going to say Lex and Tokenizer and Lex. We'll cargo format first, of course. So what happens now if I try to run my compiler on my test.code? It looks like it actually outputs a binary, which is kind of incredible. I was expecting it to give me some kind of error. So let's go back into that test.code, right? And let's make a typo. Let's put an ampersand there where it doesn't belong. Let's put a % there where it doesn't belong. Okay, what happens now? Lex token. So we see that this symbol, okay, the line number doesn't work. So actually it's a bit of a dud error, but it tells us it knows the exact spot that this goes wrong, and in theory, if we're counting line numbers, it's going to feed that back up to us directly. So let's ignore that this changes here. Let's just pretend that's not there. Let's see if we can count lines. Okay, so we've got this type stir state, and stir state has this line number field, it initializes to 0, and in theory, we're going to call this line feed function every time we see a new line character, and that is going to advance our line number. Okay, so how do we do this? We're going to have to use something a bit more manual, I think. We're going to have to say something like, if input.is empty, let's say if sum c is input.content.first. Next, input cars. Let's say next, input.next, because this is a method that I already wrote. Here's one I prepared earlier. If c is the new line character, then do something. Otherwise, just treat it like the normal whitespace function. But if it's the new line character, then we're gonna have to say our result is gonna be okay. So what is car result again? Car result, a string state A and a car. So we're gonna say input.linefeed, and the character is just gonna be the new line character. Otherwise, if it's white space, just in general, we're gonna say, okay, input suck. So we're gonna do the next input and the character. Otherwise, this is an error. And the error is gonna be car failed predicate. Car failed predicate, we're gonna say got C name white space. Cool. So this is just what this function does. We're writing it out manually so that we can count new lines as well. And don't come at me about carriage returns. I don't know. There's other kinds of new line, I'm sure. This is too simplistic, but for now we're gonna do it like this. But what happens if we get to the end here? So this is what happens if there was nothing in input. Then we're gonna need an end of input error, which we already have. Thank you, Cricket, for the high quality. This is a valid, suck is a valid name, okay? Suck is a very sensible name for the successor, right? Get your mind out of the gutter. This is computer science. We have no room for such juvenile tomfoolery. And trust me, I know all about tomfoolery. Okay, so does this build? Not quite. I didn't actually read that error. That's okay. It's because I didn't have enough brackets around things. I could just infer from context. I kind of saw brackets and could work out from context. That also was the wrong character. Yes, because we want to call this on the actual car, not just on a car in general. Okay, so what if I do this now? What if I go back to test.code? Cricket, have you been playing Deadlock at all? I played last night with Westy and some of his IRL friends, and it was pretty good. Honestly, the game's pretty good. Okay, line 5, position 10. So that's line 6, but that's okay because we're counting from 0. And position 11, which again is okay because we're counting from 0. Should I just start counting at 1? Is this 1 indexed? Is that because this is like a human thing? Are we 1 indexing? Does that make more sense? Line 6, position 11. Oops. Line 6, position 11. This exact character. It kind of points us right there, right? So this is a gigantic improvement over anything we had before, and this is a huge reason why. This is actually why I put off tokenizing for so long, because I knew that if I did it properly, once I understood a bit more about how errors flowed through our program, I would get error reporting kind of for free, because I could just put metadata about where a token is in the file in the token. Anyway, it was silly anyway. I should have done this much sooner, but that's kind of cool. That's a much better error report. Got an invite, didn't install it, been playing Overwatch to death, so you've had your fill of MOBA shooters. Deadlock is much more MOBA than Overwatch. And like the reason I didn't like Overwatch is it was too much of a MOBA and I just wanted to shoot things. But somehow Deadlock is so far down the MOBA path that I had more fun with it. I don't know, it's weird. I've also heard people say recently, because people have been talking about like the shooter to MOBA spectrum and where games fall on it. I've seen people saying that Paladins is more of a MOBA than Overwatch, which seems insanely wild to me. But also I haven't played Paladins since whenever. I probably played it with you. I don't know who I was playing it with back in 2016 or whatever. It's a long time ago. Old man games. Despised Overwatch for its MOBA elements too, yeah. Yeah. I just wanted to left click on people as McCree. Probably MSV. I definitely played with Strahl and Ultra and maybe ZTK a few times. The old days. I'm pretty sure it was Jake that invited me to Deadlock, but I'm not sure. He had a Steam profile name that I won't repeat. But yeah, the old not safe for work gamer crew. And different time of my life. I did play a video game until after midnight last night though, so that was that was a bit of a flashback. All right, so that's kind of cool. Let's add that because that was amazingly simple. Let's actually format. Cool. Now I do need to clean up some of this weird temporary printing that I did. Let's this. And this one, let's get rid of as well. We'll keep that. Okay. Excellent. Excellent. What next? Well, let's do a quick make clippy because I'm sure there will be things. Explicit lifetimes could be elided. Ooh, I like that. I like that a lot. Just infer the lifetime because they just live for as long as the function. We don't need to actually be this specific. The compiler can work it out. As long as we know, like we have to say that there is a lifetime because the type is generic on a lifetime, but we don't actually really care. And I think we're actually going to see a lot of this in particular. Can this all be elided? Because it's all the same lifetime, right? So the compiler, if we just put this underscore, the compiler's just going to try and put whatever, square peg it can in a square hole, and they're all gonna, it's just gonna put the same thing everywhere, right? It's not gonna try and do anything fancy. So, does that mean I can do this? Does that mean it doesn't even need to be generic? Except you've got to actually close your brackets. Implementation of FN is not general enough. Okay, hold on. I think I went too far in a few places. I think I may have gone too far in a few places. Change this to S0. Will do. Could be elided. Cool. This, I'm really happy about this. I felt like I'd written too many lifetimes, which is a very rusty problem to have. Excellent. Immediately reference that is immediately dereferenced. Let's not even do that. Skip white space. Now, I'm kind of scared of some of these, right? Once it's in a function closure, I might need to be more explicit. Oh, that's not what I wanted. Make clippy. Cool. Excellent. Sorry, I just had a text from my parents. I sent them a fun video because I made a tin whistle today out of a bit of PVC, so they wanted to hear it, and they think it sounds good, which is nice. So that was a fun little project, you know, out in my driveway, got a folding table out. Neighbors thought I was weird, just with a hacksaw and a bit of PVC pipe. Cool. Cargo FMT just to be safe. Git add lang. Clippy, mostly lifetime. Is this the word that I want? Is Elysian a word? Elided? Elide? Is Elysian a word? No. No. Are there... No, that's not what I want. Allied. Allied. Allieds? Allied. Allighting? I don't know if that's a word. I might have a permanent not word in my Git history forever now. A future employer is going to look at that and not give me a job because of it. They're going to know. They're going to be like, man, I wasn't sure, but that really confirms that this guy is in fact a moron. He's just making up words in his Git commit history to make himself sound smart. Okay, so language. We're going to fix... wait, what's this? What was I doing here? Oh yeah, if we've tokenized our input and there are any tokens left after the input, that should be an error. However, the way my tokenizer is defined, that should never happen. So I think we just quietly let this one sit and never speak of it again. I think that's what we do. So inline ASM, let's undelete inline ASM. So the way inline ASM works, you've got this special, this is a symbol. Because it has an exclamation mark in it, it is not a valid identifier. Okay, so this is a symbol. We then have these opening, we have arguments, we have a closed thing. Now, none of this machinery exists anymore. Lift to state, it's gone. With confidence, no longer exists. These all got so much simpler when I stopped tokenizing while I was parsing. It's kind of funny that. It's almost like tokenizing and parsing at the same time is bad. It's almost like people told me that I should have written a tokenizer sooner. Anyway, anything that's not one of these two characters was fair game. Now what's going to happen is, right, we're going to have code that looks like this, test.asm. We're going to have code that looks like this inside of a function. So this stuff is already going to be broken up into tokens. So do I try to use this? No, because again, the problem is that the new lines are significant, right? So I want to untokenize for a little while. I want to untokenize this stuff and then reprocess it using my normal line-based assembler. So I want to step out of whatever space I'm in when this... I'm going to undo tokenizing because new lines are suddenly very significant to me. In my programming language, I actually, new lines don't really hold any special meaning, but here, they're the main delimiter, so it's kind of important. Right, so it's kind of hard to bridge the gap between these ones. But that's okay, we can do it, because we're clever. So we're going to write a function called untokenize, okay? And the thing we need is every token until we find this end character. So we'll assume we have that. We'll say tokens, we'll have a slice of lexed tokens. And we're going to give back a string, just a string, maybe a vec of string that are the lines. Okay, so we'll say let mut out. we'll make a new vector, and then at the end we'll just return out, and then in between we have to populate it with all of the lines of assembly in our function. So current line. Okay. Well, I guess first things first, right? We have to say, let's do this. If let, actually no, hold on. Let's say let current line equal if let tokens len, if let, sorry, some token. So if we can get the first thing in this slice, if there are one or more things in this slice, then then we just return token dot line number. Otherwise, we just initialize this to like -1, and it doesn't matter because we never can use it. So for token in tokens, for each token, for every single token, if token dot line number is not equal to, see, line number should increase monotonically. Should never go back down. That should be impossible. So I think we can just say if they're not equal. If they're not equal, it should have gone up by 1 or more. So line number, let me double check that this is what it's called. I'm pretty sure it's line number. Line number. So if the current line has changed, then we want to, this needs to be mutable. Then we want to, let's say a vec string. Sorry, it sounded like someone was just trying to open my back door. I might have to go and have a look at that. Well, that was alarming. Cool. No one invaded my home, so that's nice. Really get the heebie-jeebies sometimes with those noises when you live alone. Hold on, Super Cricket has linked a video, and I might open it off stream first. Hold on, what is this? What is this? Cricket says, don't play it. Yeah, thank you for the warning. I don't think you could hear that on stream, right? I think I've got my desktop audio off. I have been turning desktop audio on in OBS because I've recorded a couple of Quake videos, and I do them with sound. So dangerous times. So line parts. So basically every time the current line changes, then we just say, well, we line parts join. I think we can just say join with a space. That's fine. We don't care how much white space is between them because white spaces are delimiter. Our assembler tokenizers in a much simpler way. So we'll say out.push. We'll add on. Why do I have so much white space there? Anakin Luke, welcome. How you going? How are you going? Glad you could make it. Glad I've rolled over into South American times. Line parts.join. So then we're going to say line parts is a new vec. We clear it. We get rid of all the bits. We probably can just use a clear method instead of new, but we'll just go new for now. And then we need to push however we stringify these tokens. And let's call it toString. Let's call it toString. Now, value, lex token, value toString. Yeah, and this is fine. This is actually exactly how it should be. Now, there's a problem here, and the problem is that something like colon loop will turn into colon space loop in this system. So we kind of maybe need to interleave them with the number of spaces. Like, we can get all this information, right? We have all this information. I just don't want to do the work. how do we... So we can do it. We can do it. Let mut position in line equal line number token position in line. Otherwise we do -1 because there's no work to do and we'll just return an empty vex straight away. 8 AM in South America. Wow, that is pretty early. That's earlier than I was up today. Congratulations. Okay, so this is okay. We can do this. Maybe I should just make this a string. I don't know. Maybe it's better to not mutate this. So now we're just going to join with nothing, right? We're going to do this. We're going to say current line equals token.line number, and we're going to say we're going to say line offset equals token.position in line. Okay, nice. This is good. This one's easy. Otherwise, oh boy. Otherwise, we've got to do some thinking. So if we've moved on to the next line, then we push the previous line, and we start a new line with this new offset. Now we want to say, so this token, so we need to say space offset. It's going to be the line offset. It's going to be token position in line minus this, right? And it's going to be this -1. This is the number of spaces that we have to advance to get to that character. If these characters are only one apart, that's 0 spaces. If these characters are more than one position apart, these tokens are more than one position apart, we're going to have to pad that out with some spaces. Otherwise, they're not going to format right. We'll get this issue where, you'll have colon space loop instead of just colon loop. So space offset, then we want to I guess we just do this. We need to push line parts, we want to push this many spaces. So Rust make string with n spaces, or with a single character repeated n times, this pattern. Oh yeah, let's do it the Haskell-y way. Right? So do this thing 10 times, except we're going to do it space offset times. Right, map this iterator into the character space and collect that into a string. Cool. And then we'll say line parts push token to string. Let's update the line offset after this, because I think that's a bit clearer. Beautiful. And I think that's actually all we have to do, right? We'll get those nicely spaced out, preserving any gaps that were there. And then when we get to the end, there's one more thing we need to do. There's one more thing. We need to say if line parts, if this... Actually, no, there's no situation where this is empty, unless we haven't put anything in it. Let's say if it's not empty, if this is not empty, then we want to say out.push line parts join. Then we return out. Perfect. Too good, too good. I think this is a nice little algorithm for restoring, for untokenizing this input. I think this is good. I think this is good. And we want to, instead of doing this, right? So let's get rid of this. Let's get rid of this. Actually, I guess what I really would like is just to say not matches symbol this, anything up until the symbol that, the symbol close bracket, followed by the symbol close bracket. Now, this actually, when we build this block, we do it with just this string, and this is because we can't actually process this assembly. We could pre-process it a little, but the way my compiler works, this is just a string blob until pretty much the last stage of compilation, because the way label resolution and stuff works. Oh, not necessarily, actually. I think it's deferred now. Anyway, this happens at a later point in compilation. Untokenize body. Beautiful, beautiful, beautiful. Repeat 0, not matches. Okay, so I don't have a not combinator, which is interesting. I really should have a not, shouldn't I? Not sounds useful. So what would not look like? Not would be like pub function not. Not matches. T, E, F. So it takes a parser. Function that gives back a STE. So what does symbol give back? Hold on. Ling. Gives back the actual string content of the symbol. That's not right. What if I change symbol? What if I... Oops. What if I change symbol? What if I go back to fn symbol? What if I make symbol give back the actual token? Because then, you know, we'd be fine, right? Except... it's not quite that simple, is it? It's not quite that simple. Let's not change this. Let's not change this. I might need to just write this manually. Annoyingly. Like with a loop or something. I'd rather not. I'd rather not. But I might just have to write this with a loop. It's the different typiness of it that I don't know if I can quite deal with. So let's say let mut body equal vec new while not while what do we while loop. Let's just loop forever for a sec and see what this looks like. So if let some token is input first, next, what did I call this? Struct state input, what did I suck for? First, I called this first. First, the first token in this list. What do we do with it? We try to if let lext token kind symbol. So if it's this, if it's this closed thing, then we do this. We do this. We're gonna indent you a bit. That was too much. Just 3. Beautiful. Okay, so if we've found the end of the function body, then we return the untokenized body. We're gonna have to borrow that. Otherwise, we're just gonna add body.push token.clone. We've got to clone it here. We've got to take ownership. That's the only way this is gonna work. Otherwise, we're gonna have to return an error, and this error is gonna be parse. What is this error going to be? Hold on. Oh, we do still have with confidence? No, identifier now returns a confidence error. This isn't needed anymore. We're going to have an error. It's going to be a confidence error. Hold on. Error. And I'm going to be pretty high confidence that this is what went wrong here. Parse error end of input. Cool. So does this blow up? Yeah. Yeah, it does. It absolutely does. What next? What else have we got? Not matches. We're not doing that. That's too tricky. Okay, we'll just go 0, 0 then. That's fine. Expected string found stir, toString. Annoyingly, this probably like really thrashes the inner loop as far as memory allocation, but we'll deal with that for now. Method calls are not allowed in patterns. Ah, excellent. Wonderful. Can I do this instead? Expected string found stir. Ugh, that's really annoying. That's so annoying. How am I meant to deal with, how am I meant to, can I not match against a string? I guess I just have to say S, right? If S equals close bracket, because we can do this. So if this, we do that. Let's return in this case. Oh god, this indentation has gotten really, really disgusting. So if this falls through, because it's not a symbol that has this exact value, then we just push. Cool, okay, good, 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 good. Expected string found vex string, that is fine, because we're just gonna join this on the new line character. They're just gonna be lines. Token.value, data moved here, that's also fine. I kind of tried to do that before. Okay, so we are dealing with inline ASM, inline ASM. I've got tests for inline ASM as well. Tests that fail. Expected token ASM. Cool. Why did that? What? Expected token ASM. Did we not get the token ASM? Line 1, position 1. It's right there. Cool. Let's do this thing where I println lext, because this means that I can, when a test fails, I can see exactly what the input was, which is good. Ah, now this I didn't consider. Of course, right? It breaks this. So this actually needs to be two things. This actually has to be the name ASM and then I'll say O1. This is the symbol exclamation mark, because these things now get broken apart, right? So this means you could do ASM space exclamation mark, and yeah, it's a bit jank, but we'll survive with that. We'll survive with that. Now it looks like it hangs forever, because obviously we're just looking at the frickin' first input. We'll call this SN equals S5. Now, obviously, we don't actually want to look at the input. We want to look at whatever it's advanced to here. So we'll say SN, blah, blah, blah. We push here if we get to this point, and then we want to say SN equals SN dot suck. It's dot suck, yeah? Dot suck, the successor. Okay, here we go, here we go. Now we're not going to hang forever. Okay, now we've broken something else, which is interesting. Inline assembly, what goes wrong here? Subtract with overflow. Does that mean that I did my subtraction in the wrong order? Because these do increase monotonally. Line 1, line 1, line 1, line 2, line 3, line 3, line 4. Oh, hold on, it's the other one, right? It's the position in line 1, 4, 6, 12. Okay, so untokenize position in line minus line offset. So I would think, oh, hold on. If space offset greater than 0, we only push this thing in if the space offset's greater than 0, in which case we do that -1, right? Is that right? If it's greater than 1. If it's greater than 1. Because an offset of 1 means that it's just the next character. That's fine. That's fine. That's what we expect. Okay, so let's do that. Let's do that. Ah, now printing it back out, of course, is a little bit troubled. I don't know why. Because we're doing this left equals right test, it actually kind of blows up. You would expect it to be the same, maybe. Maybe. Left and right. So which one's left and which one's right? Inline ASM. Left is the expected. So we have this new line here. Now, this new line comes from... So maybe I actually need to change how the AST prints this out now, because I suspect I did something in my AST to make this look nicer. Top level. Inline ASM, name, body. So yeah, let's maybe put a new line here. See if that looks a little more like it. This spacing is still not quite right. I don't know why we get this bigger space here. It's no doubt something I've done. It's almost certainly me. But I guess what's more important is that I can probably just do this. Actually, no, hold on. I do want there to be new lines around this. Otherwise, it will just be in line with the curly braces, which isn't great. So we've got these new lines probably, but why are there 3? Why are there 3 spaces here? So we have this. Where is our open bracket? Open bracket, position 27. Line 2, identifier add, line 2, position 1. A, line 2, position 5. What the hell? ADD. Ah, yes. I see what's happened here. So this spacing's fine when they're only one character apart, but I'm looking at the start of this token and the start of this token to work out how much spacing. What I actually need to do, is to factor in the length of the token as well. So it's going to be position in line minus token dot... Oh dear. So let's say token stir is token to string, and I sure as hell hope that whatever I serialize out is exactly the same length as whatever I read in. So we'll say this minus position in line, the offset of... Hold on. So I want the offset. I want this plus the... I want this offset plus the length of the previous thing. Plus the length of the thing. Maybe even the offset should be the position in line plus the length just from the get-go, right? Because then we would get 0 if we tried to subtract them out, so that would work. So what if we say let token stir is token to string, and we add on token stir.len. So if it's 1, we're going to get the end position, right? The start position for 1. If the length is 3, we're going to advance 1, 2, 3. We're going to be at the position at the end. So if there's a token immediately after, its position in line should be this. If there's a space, it should be 1 more than this. So this is actually good. This fixes this weird offset thing. So we're going to do the same thing. So my position in line minus the line offset, right? This is good because this is now 0 if I start where the previous token ended, right, in the next character, or 1 or more. So I don't need to do the subtract 1 anymore, basically, in conclusion. Here, so this range, we don't do this anymore. Now the line offset is this plus token to, let's let token stir is token to string. We're going to update the line offset first because then we don't need to move token stir, and then here we move it when we call this function, and that's okay because we've already taken the length up here. So let's try this. This might blow up on me now in a different way. And is this another, yeah, subtract with underflow. Okay, that's fine, that's fine. So let's, again, just do the dumb thing and println, debug println. We're gonna say offset calculation. We're gonna take the current line offset, token, we'll look at token position in line, and we'll just do it like this. We'll debug print the whole token, and then we'll look at the unexpected, add a semicolon, that makes sense. Okay, so we're gonna get a noisier output. We're gonna get a noisier output. Offset, Lex token, add, position in line 1, 4. We're saying the line offset's 4 already. How did that happen? Oh, that happened because this is the first thing. So actually the position in line should be 0, right? The line offset should be 0, I guess, or something like that. Yeah, okay, cool. And now we just have this awkward case of there already being one space because this starts at 1, not 0. So now if this starts at 1, this should match. And when I go to a new line, it breaks. And it breaks because when I update the line offset, I do it manually. And I don't do this same calculation in the same way because when you copy and paste code like this, it's really janky. So now it should match and pass, and it does. Beautiful. So that's a bit of a funny test to try and fit into, but that's okay. So Lex identifier now breaks, and that's a bit weird, and that's a bit concerning, because I thought we were doing fine there. I thought we were doing really fine there. Oh, hold on. Lex identifier, that's just because we're now 1 indexed. I accidentally made a commit. And I hadn't fixed that. So what's the other test that broke? It's probably test tokenize. Yeah, so get ready for this. So we just have to increment all these numbers by 1. Now, can I... Okay, so I can do that. Can I, if I go Control V, can I highlight all these numbers? Hold on. Am I about to do some real Vim magic? And then, wow. I love when you unexpectedly do Vim stuff that makes things work. Okay, hold on. Whoa. What went wrong? Test tokenize. It's this one. Some of these did not increment. Oh, for God's sake. What happened here? How did this happen? 18, 20. So what have we got? Left not equal right. 1, blah, blah, right. So which is on the left, which is on the right? Left. So right is 1, 1, yes. 1, 5, yes. 1, 9, yes. 1, 12, yes. 115, yes. 116, yes. 118, yes. 120, yes. 121, yes. 122, yes. 123, yes. 124, yes. 125, yes. Oh, hold on. That's funny. So I'm like, why were some of these numbers not incremented? Let's look at the numbers that weren't incremented. Okay? These are the rows that had numbers in them already. So I actually incremented the value of the number that the token had, which is a really funny way to cause that to break. Okay, so now that works. Oh, and also, hold on, I need to go back into my lang tests compiler and re-enable this and make sure this works, because it's all well and good if my weird round trip works, but if I don't actually test the assembly, and yeah, okay, it breaks. Of course it breaks. Let's, hold on, inline. So let's just run everything to do with inline assembly. So what breaks here? Tag none, expected token type. Line number, line 9, position 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Strange. Very, very strange. And I think, Japfo actually told me this. If I was paying attention to chat, I got really in the zone there. I got in the debugging zone. I think this is going to be an off-camera bug to solve. I think that's about all my brain can handle for tonight. I need to go do some music and stuff. I've got this wonderful tin whistle that I made myself today that I need to do some more practice on before it gets too late to do so. My camera's not picking it up very well because it's ghostly white PVC. It's very exciting news. Let's find someone fun to raid. And then we can keep the party going. GG's good stream. Thank you, Cricket. Thank you very much. Always happy to take requests for any cool streams to raid. Otherwise, I'm going to find something cool in this list. Someone looks like they're playing Quake in software and game dev. Mission viewer for Thief 1 and 2. Let's do that. Bit of retro game stuff. I love it. Let's raid this channel. Let's see how they're going. Thank you everyone for tuning in. I've got lofty plans for the coming few weeks. Once this weekend is over, oh boy, just you wait. So thank you so much. Let's go raid this awesome looking channel, and I will catch you next time. Bye.